Hello, I am Sankudip Roy. My topic in object-oriented programming is association. Now, going on to my first slide, introduction. In the world of software development, object-oriented programming is a powerful paradigm that allows us to model real-world entities and their interaction in a more organized and intuitive way. Java, being an object-oriented language, provides robust support for implementing OOPS concept and including association. Association is a has-a-type relationship. Association is a relation between two separate classes which establishes through their objects. Association can be one-to-one, one-to-many, many-to-one, and many-to-many relationships. There are two types of association. One is aggregation and one is composition. Now, what is aggregation? Without existing container object, if there is a chance of existing content object, then container and content object are weakly associated, and this weak association is known as aggregation. Like in this example, this final class college, and inside that there is professor. Now, without this college, this professor has an independent identity. This professor may be swapped or even completely removed. Not only that, but the outside world can still have a reference to the professor. Tinker with it regardless of whether it is in the college. So it is a weak relationship, that is aggregation. Now in composition, without existing container object, if there is no chance of existing content object, then container and content object are strongly associated, and this strong association is known as composition. Like in this example, this final class is college, and inside that there is branches. Now if there is no college, then there is no existence of branches. So in this case of composition, the branches is completely encapsulated by the college, and there is no way for the outside world to get a reference to the branches. The branches lives and dies with the college. Now, benefits of association, like flexibility, we can easily manage the relationship between books and libraries, allowing the dynamic updates to the collection. Modularity, remain independent, promoting a modular design. Code reusability, this is a very important benefit. The same book class can be used in multiple libraries, promoting code reusability. Easy maintenance, as classes are decoupled, maintaining and extending the code become less error prone. A simplified representation allows for a clear and intuitive representation of real world relationship between entities. Better collaboration. Association enhances collaboration among developers working on different parts of the application. UML visualization. UML diagrams facilitate visual representation of association between classes, offers a clear overview of the relationship, making it easier for developers to understand and communicate the design. Now, best practices. Understand the relationship types. Differentiate between aggregation and composition. Choose the appropriate type based on object ownership and life cycle. Use multiplicity appropriately. Define cardinality one-to-one, one-to-many, many-to-many based on requirement. Avoid unnecessary multiplicities. Minimize bidirectional association. Limit bidirectional associations unless necessary. Reduce coupling and enhance code clarity. Implement encapsulation. Encapsulate data and provide clear interface for interaction. Avoid direct access to internal representation. Avoid cyclic association. Careful with lifetimes and consistency in naming. This is very important. Use meaningful and consistent association names. Improve code readability. Conclusion. Association in Java facilitates modeling complex relationship between classes by establishing connection between objects. It enhances modularity, flexibility, and reusability. Thank you. I'm ending my presentation.